Okay, what we're going to look at now is how the average and the standard deviations all look in the graph, or how they affect the graph. So I just copied the data down here. So we have the women's average and the men's average, and then these are each of the standard deviations. So this is 1 standard deviation away, 2 and 3. Oops, 3. This is 1 standard deviation away, 2 and 3 standard deviations. Okay, so let's go ahead and take a look at the graph. So we can see that this x-axis on the bottom represents the height, and the y-axis, it says it represents frequency, which is basically like how often will it occur. So if we look at this curve, I'm going to first start with the women's curve. I can see that this is my highest point here, and then notice how that's the women's average height. It's at 65, and that's what we said the average height for women was, at 65. So on a graph, your average will have the highest point of the curve because the average has the highest frequency, because the average is what occurred the most. So we're going to say the average has the highest frequency, which just means it occurred the most. So if you went around and surveyed women, you would find like the majority of women are about 65 inches tall. Average has the highest frequency, thus it is the highest point on the curve. It is the highest point on the and then it's not just called the curve, it's actually called a normal distribution curve. So the average has the highest frequency, thus it has the highest point on that normal distribution curve. And then the same is true for the men's graph here. So if you look at the highest point for the men's graph and we go down to where it is on the height, it had occurred at 70, which was our average height for men. Okay, so if we look at each of the standard deviations, so again, I'm going back to the women's graph. I'm going to start with this first one, so 61.5 and 68.5. So 61.5 is about here, like right there. 68.5 is about here. So this data is where this is all 1 standard deviation away from the average. So again, 68% of women will be between these heights here. And that's why the frequency is still high, but it's getting lower. Whereas if we look on the men's side, so I'm going to kind of clean this up a bit so we can see. I'm going to go 1 standard deviation away, which was 66 and 74. Sorry, that got cut off. So going over to 66 would be right about here. And over to 74 would be right about here. And then we could keep that process going, like going over to 62, over to 78, which was our next standard deviation, and so on. What you might notice is that this men's curve is a lot shorter than the women's curve. That doesn't mean men are shorter than women. That means that there's a greater gap between heights, basically. Or another way to say that is that there's a larger standard deviation for men. So the women's standard deviation was only 3.5 inches, whereas the men's standard deviation was 4, because men's height does vary a lot more as compared to women's height. So the reason that the men's graph or the men's curve is shorter is because they have a greater standard deviation. That's basically saying that we have our average, I'm going to do it in green, we have our average here, right? The gap between our average and the next, like 1 standard deviation, is larger than the gap was between the women's average and their standard deviation. So you can see here that there's a bigger gap going on from the first standard deviation to the average as compared to the women. So the reason that the men's graph is shorter is because they have a higher standard deviation. So to put it all together in a sentence, we could say, so the reason that the normal distribution curve is higher for women is because they have a smaller standard deviation. So we could say that the curve for women is higher. The curve for women is higher. Oops. Because there's a smaller, I'm not going to write all of it, smaller standard deviation. Whereas the other way, the men's curve, I'm super shortening this, sorry, is short because there's a larger standard deviation.